Next, we will go to the binary multiplication. Okay. In binary multiplications, so we consider again the same number A multiply with B, then you have the result, which is product. Zero multiplied by 0, 0 multiplied by 1, 1 multiplied by 0, and 1 multiplied by 1. Okay, so 0 multiplied by 0, you will get product of 0. 0 multiplied by 1, you will get 0. And 1 multiplied by 0, you get 0. And 1 times 1 multiplied by 1, you get product of 1. If you notice, for binary multiplication, the product will result as 1 only if both of the numbers are 1. You see, 1 multiplied by 1, only then you will get 1. But if the other operation, if other numbers, which is you have even 1 0, then it will result to 0. For both 0, certainly it will be result in 0. So this actually the same as AND gate. Okay, the rule for binary multiplication are the same as the AND gate. What is the AND gate? Okay, this one you will study later on in detail in the further chapters. Okay, this is your AND gate. Okay, so if you have 0 0, then your output will be 0. If you have 0 1, then your output will be 0 also. If you have 1 0, your output will still be 0, but only if you have both input as 1, then you only have output of 1. Okay, so this is AND gate. You will study about this later on. Okay, now without further ado, we go to the example. Multiply 7 by 5 in binary arithmetic. Okay, you see this question, it doesn't say whether it want to be in 5-bit binary, 4-bit binary, 3-bit binary. So you are not restricted. Okay, so you can use as minimum bits required. Okay, so first you see what is your 7 base 10. Okay, this one doesn't mention what is the base, so it's base 10. Next one is 5 base 10. Okay, so you need to convert first in the binary equivalent number. What is 7 base 10? It is 1 1 1. What is 5 base 10 to in the binary number? Is 1 0 1. Okay, so let's say the question is asking multiply 7 by 5 in 4-bit binary. So you need to add 0 here, 0 here, so that it becomes 4-bit, right? So here doesn't mention anything, so we can use as minimum as required, which is 3-bit is enough. So this is your multiplicand, and this is your multiplier. Okay, now we multiply. 1 multiplied by 1, you have 1. 1 multiplied by 1, you have 1. And 1 multiplied by 1, you have 1. Okay, now we go to the next. 1 multiplied by 0, you get 0. 1 multiplied by 0, you get 0. 1 multiplied by 0, you get 0. Actually, any number multiplied with 0, you get 0, right? And then we go to the next one, the last multiplication. 1 times 1, we get 1. 1 multiplied by 1, 1. 1 multiplied by 1, 1. Then you add all the results, okay? So this one, we call it as partial products. Mean it is not finished partially. So now we want to have the final answer. 1 times 0 times 0 plus 0 plus 0, so you have 1. 1 plus 0, you have 1. 1 plus 1. Okay, what is the answer? 1 plus 1. So refer to the previous. 1 plus 1, so you carry 1. Okay, so 1 plus 1, the summation is 0. You carry 1 here. Then 1 plus 1 again, another 0. Then you carry 1 here. So 1 plus 1, you have summation is 0 and you carry 1. Okay. So multiply 7 by 5 is actually 1, 0, 0, 1, 1, 1 equal to this number, which is actually 35 times 35 binary of 10, which you know, right? 7 times 5, you will get 35. So this is the result of the multiplicand. Every bit in the multiplier is examined from the low significant bit. Okay, if the bit is 1, the shifted multiplicand is added to the product. Now we go to the last arithmetic operation, which is division. Okay, binary division is similar to long division in decimal. The algorithm uses the shift and subtract method. Just as in decimal division, it is not possible to divide by 0. Okay, now we go to the example. Divide 31 by 5 in binary arithmetic. First, you need to know what is the 31 base 10 in your binary equivalent numbers. And the next one, you need to know 5. What is 5 base 10 in the binary numbers? So this one is too long, right? So you can just use this 31 decimal. Okay, what is the binary equivalent? Is 1 1 1 1 1 base 2. 5 is not long. You can actually know that is actually 101 base 2. Now you divide, okay, divide 31 by 5 in binary arithmetic. So you 1 1 1 1 1 divide by 101. So this is your divisor. Okay, divisor. Okay, this is your dividend. And this will be, here will be your quotient. First, you see this is 3 bits number. So we take until 3 bits. So we have 1 1 1. Is 1 1 1 is equal or greater than 101? Yes. So we put 1 here because it is equal or greater than 101. In this case, it is greater, right? 111 is greater than 101. So now 1 times 1 multiply 101, you put 101 here. Then you subtract, okay? 1 minus 1, you get 0. 1 minus 0, you get 1. Then you take down this 1 here. Is 101 is equal or greater than 101? Yes, it is equal, right? It is equal. So here you can put 1. Okay. Then you multiply 1 with 101, you have 101. Then you further subtract it. 1 minus 1, 0. 0 minus 0, 0. 1 minus 1, 0. Okay. Then you take down this 1 here. Okay. Then you ask yourself again. Is 1 is equal or greater than 101? No, actually it's less. So that's why you put 0 here. 0 multiplied by 0, you have 0 here. You subtract again, you have 1 minus 0, you have 1. Okay. So this is your remainder. Okay. So the results of 31 base 10 divided by 5 base 10 is actually 110 remainder of 1. Okay. You can write the complete operation. 1 1 1 1 1 divided by 101. Okay. Thank you.